So I have used AutoML tool from Google to complete this uh, assignment. So there are these 5 steps that we need to follow: import, training, and evaluating the models. Before evaluating the models, doing the modeling, evaluation, and predicting using it on the test data. So in order to complete this video, I have prepared a presentation that I would like to use it as an index view. So let's see the data set that was given, which is of CCPD data related to electrical energy. There are 5 various columns or variables in the data set: temperature, ambient pressure, relative humidity, exhaust vacuum, and the target variable which is supposed to be predicted is net hourly electrical energy output, acronymed as P. So moving to modeling approach, for this problem, I think regression machine learning modeling would be appropriate because it is not a classification problem and it is largely related to predicting the energy output and related to the numerical variables that were given to us. So regression is the appropriate modeling that is applicable for this problem statement, and the appropriate and relevant metrics for this regression model are mean absolute error, root mean square error, and root mean square logarithmic error, so on and so forth. All these relevant to any regression problem. But we would see during the modeling what is the right one to use and what would be the appropriate one. So let me show you this Google AutoML thing, which I first time I have used to apply this. So this is the import part. So I have selected upload files from the local computer because I have saved in my downloads the CCPP data, and I'm going to browse. So uh, select files. So I would select this, and then I can click on import. But I would not be doing this because I already imported and it is going to take a lot of time in order to show this. And in order to complete this video in the relevant time span and recommended time span, I'm going to skip this part. So let me go directly to the model that I have already trained on this data set and then explain you the different parts. So second is in our thing is modeling approach, which I have explained regression would be the right one. So as you can see, the data set has been imported. There are 5 columns and 9,568 observations are there, and every variable is numerical. You can see here the different column names and the data type of it and everything, and related to the distinct values and what is the correlation with the target. Everything is being shown. The brief data observations is being are being explained here. So I've selected the target column as PE, which I have done it prior, and then I click on train model. Once I click on train model, it will ask basically some parameters such as how much time that I need to allocate the budget in terms of node hours and model name, and whether all the columns should be selected or not. So in this case, I have selected all the 4 columns because I would like to first understand what is the relevance and importance and impact of each of these column towards the target variable of PE. So hence, to start with, I've selected all. So once we train one model, then we can see what column is least important and can be eliminated as well. So there are some advanced options as well, where we can explicitly mention align with the specific metric that we would like to, and we are interested as per the business scenario. In this case, I'm going through the general root mean squared approach because this is a regression modeling that we have chosen, and I'll give 1 as the node hour because I'm using the free credits. I would not be using more than 1 hour. The more I use, I think based on the data set, it is recommended what is the appropriate time to use. But general indication is the more number of hours, the more precision the model would be kind of thing. So I'm going to start 1 and train model. Again, I'm skipping this part of train model execution part because it is going to take almost an hour to completely train the model. So since I've already trained the model earlier, I'm going to directly move to modeling. So this is how the modeling will be shown initially. So let me just quickly go back to my indexed presentation. So model building. So here we understand the various features and its importance towards the target variable. So you can see the 2 variables AT and V are very highly inclined and have a major impact towards the target variable PE, and the last two AP and RH have less impact. Although it is less impact on the predicted variable PE, I'm going to include all the four because removing these two variables, even though they seems to be having less impact on the prediction variable, results in a much smaller feature sets with which we may not be able to understand the entire patterns. First, let us model through all the features and then we can understand which ones to remove, or if not, removal is not required. So let me go back. So this is what we are showing. This is what the modeling metrics are. So we can see the mean absolute error is 1.895 and root mean square error is 2.98922. You can see here a brief description also, which we have learned through this course. So it is range from 0 to infinity, and the lower the value, the much closer the value towards 0, the better our model is. So since it is root mean square actually implies the larger variance to come out, hence the value would be slightly higher relative to any other metrics that we've seen. I have done two models. One is on the one first model through which we have got these kind of metrics, and second model have got slightly better metrics. So I am going to use this model in order to predict on the output data set. So we can see the full evaluation either here or through clicking here also. Either ways it goes to the same tab. So here you can see all the four columns that are included, and the different error metrics are being shown, and we can see here regression model has been the chosen one, which we also emphasized or thought of before that this would be an appropriate model to use, and we can see the feature importance that I have just covered in the presentation slide as well. So the different impact or the importance of the features towards the target variable. So let us now apply it to the data set and then see what kind of prediction values that we are getting. So I can use test and use and online prediction. So I have already deployed the model here before recording this video, hence it is showing a stick. So because if I click on remove deployment and deploy it again, it would take roughly about 20 to 30 minutes, which I'll not be doing. So you can see here what is the predicted variable and what are the values that are there and different features. And now after clicking on predict, we will understand what is the actual prediction, what is our result. So we can see here, I clicked on predict. Now the values have come. So you can see the deviation percentage as well here. So you can see what this particular feature is impacting the target variable at what degree, at what intensity, right? So overall, cumulatively, we can see here the actual prediction, baseline prediction value is 456.375. However, we could only predict, the model could come to a range of 428.325 to predict the value. So we have a 95% prediction interval, and this seems to be almost close to the actual value. So this would be appropriate model to use. So the same has been covered here as well, the model evaluation, the different metrics that I have captured here, and the model interpretation. The interpretation is that this, with having these sort of impact of features towards the target variable, is resulting in roughly with a deviation of 10%. Thank you.